Hello and welcome to the Awakening Report. I'm your host, Doug Hamp. We have a returning guest today. We have Johannan Ratz. He is going to blow our minds again, talking about quantum physics. And I've actually been blowing my own mind. I've been reading a book, a really great book. This is by George Musser, Spooky Action at a Distance. That was a phrase that Einstein came up with. Ironically, Einstein is sort of the granddaddy, at least in theory, of quantum physics. But then when he started getting into this idea of entanglement, or what he called spooky action at a distance, basically two particles can have a bond somehow between them. And when you separate them, if you cause a change in one, it will cause a change in the other, no matter how far apart they are. And he just thought that was absolutely crazy. It violated the laws of, or the principle of locality. And so he spent much of his life trying to find a way to disprove this. And it's unfortunate because quantum physics is a very solid, well, it's not solid, but it's a very well researched science. And so we're going to just discuss that today. So Johannan, it's just great to have you on again. Thanks for coming on the show.
Sure.
Yeah. Well, tell us, what is this whole thing about the spooky action at distance? I'm sure you can give it a better explanation than I did.
It started in back when the foundations of quantum mechanics. Einstein actually had come up with the idea, and he had this. He figured that quantum mechanics couldn't possibly be true because it just didn't seem to jive with our realistic intuitions of the world. And so what he suggested is that, as a counterexample, is that you have this situation where two particles are in the same quantum state together, same wave function. They're superpositioned together, one might say. And one could then separate them at vast distances. And so depending on how one measures one of them, it'll immediately cause a reaction in the other. Okay? Or more precisely, since the wave function collapses all at once, the wave function, the state will, so you have like spin up and spin down, okay? So there's particles, one rotating clockwise, the other one counterclockwise. You put them both in superposition together, and while they're both in superposition, they're neither one nor the other, right?
Mm-hmm.
And
I mean, he did this to try to disprove. I mean, this was a thought experiment to begin with, right?
Disprove
it. Yeah, it was a thought experiment because he thought this would violate relativity, and it would violate the speed of light, which was impossible to go over. And so the only solution is that they're not communicating in a local sense. In other words, they're not sending a signal from one to the other that's taking time to get there. It's actually happening instantaneously. And so there's some other mechanism that's actually going on. And I find this just incredibly fascinating.
Yep. So what they did, this is kind of how the origin of it was, and you figured, you have the two of them going on like that. You have you collapse the wave function. Neither one is spin up nor spin down before you collapse the wave function. They're both in superposition of both states. And suddenly, when you measure one over here, you force it to take on the spin up state. Mm-hmm. But because of how the two are, one had to be spin up, the other one had to be spin down, then just because the other one was collapsed and the wave function collapses instantaneous, then thousands of miles away, the other particle suddenly becomes spin down, even though there's no link between the two. And they automatically correlate this like instantaneously. And Einstein figured that this was illogical because nature kind of operates in the principle of locality, and this seemed to make space turn into kind of a nonsensical notion. Like there's, the whole notion of making sense of space is that when you interact with something, the interaction with it is, I push against my table. Well, the table moves, and that's because my fingers are pushed right up against it. If my hands are waving in the air, other side of the house, it's not going to do anything to the table,
Mm-hmm.
So the fact that it's right up next to the table means that it's what's causing the table to get pushed rather than something miles away. But in this case, he figured that science didn't make any sense in this context.
Mm-hmm. Right. Why do you think Einstein was so much against it? Was it because it might ruin the idea of relativity, or
no? In fact, Heisenberg was using used an example from relativity to prove on the uncertainty principle, much to Einstein's chagrin, because that was, his theory. So.
Mm-hmm. Right. Okay.
But he didn't like the idea of it being, this big illusion. Basically, he kind of had his realist intuition that this can't be how the world is, because it has to be a particle with a defined, state, and it doesn't mean anything for it not to be defined. And he didn't realize that the reason it's not defined is not that it's some sort of mystical state where it just is both at the same time, or violating law of non-contradiction or something like that. Is that it's neither. It's literally not there. It doesn't have a value before you look at it because it's not real.
All right, let's stop for just for a second. Some people may have no idea what we're actually talking about. I just realized that, as you kind of get into the idea of quantum physics, it starts to blow your mind until you become numb enough that you start thinking that you have known this stuff for a little while. I'm somewhere in the middle where my mind is still blown. But again, the idea of quantum physics, just a really quick recap here, is that that matter behaves both as a wave and a particle, but it's basically a wave of probability. It's not like not a wave like in the ocean, but it's a wave of possibilities. And it's when somebody actually takes a look at it, at this supposed particle, then it turns into, or collapses. That's the physics term for it actually taking one specific state. And correct me if I'm wrong here, Johann, but it was the double-slit experiment that really solidified this whole instance where they shot a single electron through a two slits, and then they would see on the back screen, they could see that there was this signature of a wave. But then when they actually put some kind of measuring device there and they looked at it, then it had the signature of particles actually going through these.
Yep, because now it had a defined state. Before it was a probability. Okay. It was,
Okay. So what we can say then is that a particle, in this case an electron, is not really anywhere until a conscious person, observes it, and that collapses it into a single point or single particle. Is that the idea?
Yep.
Okay. All right. So the implications of that are just gigantic, aren't they? I mean, this is huge.
Yep.
And of course, this was coming all out of the idea of the atomists. I mean, the atom, if you go way back to ancient Greek, they were really some of the forerunners in the idea that there were tiniest particles, which they called atoms, right? Which means not cuttable. And of course, we now know that atoms are not the smallest thing, but they were fairly close, I guess. But then they discovered something about waves, and then they discovered that light actually both acts as a wave and a particle. And then they're trying to put these two things together. And then around 1900, somewhere in there, you have this idea of quantum physics, quantum mechanics growing out. Niels Bohr is one of the pioneers of this. A lot of it actually was started because of the theory of relativity. But so you might say that Einstein gave birth to this idea, but then he didn't really like the children that he had given birth to. So
yeah.
So here are huge implications, right? Huge implications. We get that. Matter is not really there until you observe it. I believe that Einstein said, he quipped that, what, the moon isn't there if I'm not looking at it, so this idea of things not being real. And so again, he was not really much of a proponent for quantum physics, but would you agree that quantum physics has been repeated so often, these experiments have been repeated so often in the laboratory, that there should be no question that quantum physics is a real thing?
Oh yeah, none at all. In fact, it's the most of all of our physics theory, of all of our scientific theories, it's the most proven theory in all of science.
Because we keep seeing it, right? Really billions of times they've done this, where they've shot an electron or something through electron, photon, whatever it may be, and then they've observed this again and again and again, statistical analysis, and it shows that, oh my goodness, when we look, it turns into a particle. When we're not looking, it's a wave. Is that right?
Yeah.
Okay. All right. So wait a second. Did God make the universe this way? I mean, obviously that's the implication, but it seems really strange, right? It seems very counterintuitive, and I'm guessing that's maybe one of the reasons why Einstein was not so keen on it, because it was very, very counterintuitive.
Yeah, he wanted to preserve realism.
Okay, so by realism we mean what I look out, I can see, right? But doesn't even his own theory of relativity, I mean, you don't really think of that at, it seems.
It's counterintuitive, but not
Yeah.
in a way that is in violation of realism. There's still a real world that's doing. Yes, it's bizarre to have space and time bend, but there is.
Okay. All right. So what would you say are some of the big implications of this idea of entanglement? That you can have two particles that are kind of linked together. You can separate them by really an infinite amount of distance, and a change in one will affect a change in the other. That's also called non-locality.
Correct.
Some people call it precognition, but this is starting to sound like magic. I mean, this doesn't really sound like physics. This sounds like
that's welcome to quantum mechanics. A lot of it sounds like magic. I mean,
okay.
They have other experiments called quantum Cheshire cats, where they're actually able to take the properties out of a particle and float them off in free space. Like what is that? I mean, it's like disintegrating the particle down into pure information, essentially.
Wow. Okay.
And there's quantum erasers where they apparently seem to erase the past or rewrite the like create the past in the present. It's very bizarre.
Mm-hmm. Right. That if I've understood that correctly, they're shooting electron through the double slit, and they're not actually observing it until it's just about to hit the screen in the back. And then when they sort of open their eyes, so to speak, then it looks like it's been a particle all along. But they know that it went through as a wave because they weren't looking at it. But then when they open their eyes, it looks like a particle. And it essentially, it has to go all the way back to its state of origin to be a wave. Right, so that's the idea of the quantum eraser. Again, these are things that blow our mind. As somebody who studies the Bible, do you have any ideas or suggestions about how we could understand this in a biblical framework?
Well, as you've noticed, there's numerous verses in the Bible, like God speaking the world into existence. In Genesis. Then there's one in Psalms about God speaking in the world came to be, and God upholding all things by the power of his word. In the beginning was the word, etc. And there's this notion that language is somehow related to creation, the act of creation, or the sustaining of creation, which is kind of peculiar, right? It is one that's like literally is made out of his word. And it's like, what is that? It looks like they're describing, it's what words are. What are words? They're information, right? So they're describing creation as being created by and made and upheld by information, and that's kind of the biblical. If you translate the concept of word into a scientific parlance, it's information. So you treat that as information, but then you look at one of the ways they're explaining this weirdness. They're realizing that you cannot have realism and quantum mechanics go together. They just don't fit. So as a result of this, they're coming up with new theories now where instead of being made of real matter floating in empty space and all this, in a void, it's information. The space is made out of information. It's a construct generated from information. The matter and energy made out of information. And so it's like a matrix construct. And that's how they explain the quantum mechanics effects. And you can actually see, not just with entanglement, but numerous effects, direct parallels to some of the weirdnesses you see in quantum mechanics and the effects inside of virtual realities and computer games. You go on Minecraft and see the uncertainty principle in effect, for example, on the side of the game.
Okay.
Or quantum tunneling cows.
This is what we were talking about last time, this whole idea that the idea the universe might be a simulation. That would stem out of this idea of the non-locality or quantum entanglement, spooky action at a distance, whatever you want to call it. So that is a possible solution is that the universe itself, the reason you can have non-locality or entanglement is because there is no space per se, right? Just like in a video game, there really is no space. It's just a perception. We, as outsiders to the video game, understand that there's no space. We understand that it's just a simulation. But the people inside, if you could, they don't really understand that. And so when something just moves from here to there and there's no physical explanation for it, they're going to be dumbfounded. But we're going to be like, well, yeah, I mean, because it's all happening in the CPU, so it's no big deal. Is that kind of the idea?
Yeah, you're interacting with a virtual construct.
Hmm.
And because of that, say if you're in the Matrix, it looks all real, right?
Right.
The top level looks all classical. There's actual empty space there. It looks like you're moving through this empty space, and there are these solid particles there, and they're well-defined boundaries and so on. But if you were to zoom down to a very tiny level, you start to notice that the way this matter behaves is weird, and the reason for that is that at a very small level, it's not actually matter at all. It's coding, and at the classical scale, it's disguised to look as though it's a real world when it's actually a computer program running things. So, of course, some people kind of assume that because that this makes the classical world real, and the microscopic world, that's the only world that's real, but that doesn't follow. It's it's like saying the Matrix is real just because Neo can't see the computer programming effects at the microscopic level inside of it.
Mm-hmm. Right. So this is what caused Neil deGrasse Tyson to kind of freak out when physicist James Gates, he found intelligent code in the fabric of space.
That was spooky. That was spooky. I mean, it was something. It wasn't just regular random ones and zeros. It was a specific set of ones.
What do you make of that? I mean,
not certain exactly. It depends. It hinges on the truth of something called supersymmetry. Undetermined at this moment. They're trying to test that at the Large Hadron Collider. And
the super string theory, or what did you
Large
say?
Hadron supersymmetry. It's a theory about the nature of particles, and they have these theories that to account for certain symmetries, there has to be another half of the symmetry that we haven't seen. Otherwise, it appears that it's out of balance. And so the theory is that to make this apparent imbalanced symmetry imbalance, there should be this additional added part of the symmetry, and we just haven't seen it. And so they're trying to test that. They call these according to the theory, there should be particles called super partners for every regular particle. A proton, there should be a super partner. They call it a sproton or a sneutron. And then so it's this. They're looking for what would be called super partners for all these particles, and they haven't seen them yet. But that doesn't mean they're not there. It could just be that they're at a higher energy, and they're trying to test to see where they might be.
Wow. Now, what's your personal take? Do you think the universe is a simulation, or is there?
I think. I mean, whether or not it's a simulation in the classical Matrix sense, right? Like, are we living inside of some kid's computer game, or are we living in, little Matrix pods with machines in the future that are simulating a 21st century world and all that? That wouldn't necessarily follow. It could be, but there's no way to tell. But in terms of it being not real in an ontological sense, yes, it is a simulation, even if it's a quote natural simulation. It's you can demonstrate. I mean, they have demonstrated, with things like the quantum eraser, that the world isn't real. The particles do not actually have real properties before you look at them, and that's because if they did, they would have an actual defined past. The past doesn't exist. There are no particles in the past before you look at them. And then likewise with space, you can extend that kind of logic to quantum entanglement and point out that the distances between those particles don't exist before you look at them either. Now, location is a property, one of these properties that exists upon measurement. And if it doesn't exist before measurement, Well, there's this problem because space is defined by locations. Every middle school math student knows that when you define a space, you start with a point, and then to define a line, you have to have another point, and so on, and you develop this three-dimensional space out of points, or four-dimensional space, or whatever you want out of points. And without points, without locations, you can't have space. And so space just collapses. There is no such thing as defined space before collapse. Space is actually a construct being generated by the information in the wave function. You can demonstrate that with a combination of
so
particles where you look at them and quantum entanglement.
let me say that again. So space or things don't exist until we measure them.
Correct.
Is that right? So that's why it's not real. So I was going to ask you, what is real? I mean, you're saying things are not real, but that really begs
right,
the
because
question.
then what would you be looking at, right? That the whole point is there's nothing to look at if it's not real. Well, yes, that's true. There is something real. So it's kind of maybe a bit of a misnomer to say that it's not real if you look at it. There is something real, but what's real is not matter in space. It's quantum states or quantum information existing in Hilbert space, which is an abstract mathematical space.
Mm-hmm. Okay. So they're real. I mean, let's
What's
go
real
back
is explicitly non-physical.
Okay.
And so you're measuring something.
There's an entity, but it's not a physical entity. Is that what we mean by not real?
It depends what you mean by physical, too, because people have different definitions of physical, and some people will say that physical means studyable by physics. In that case, tautologically, you could say everything is physical, but it's not at that point, it kind of, the notion of something becoming physical kind of loses meaning if you give it that definition. Mm-hmm. And so the idea here is that it's not physical in the sense that, if you define physicality as that which exists within space and time, it's not physical because it's outside of that. And your interaction with it is generating the illusion that there is this construct you call space and time.
Okay.
It's a virtual reality being generated by something non-physical.
Right.
And what you're interacting with when you look is something non-physical, and then it shows up.
Okay, so the world is not real until we measure it. How do we, as biblicists, as believers in the God of Abraham, Isaac, and Jacob, how do we understand that? How do we incorporate that into our worldview? Do we see any evidence, examples of that in the Bible? Are there places where we might find some clues of such a phenomenon?
Well, the first example is right back at the beginning. Is Genesis, the creation. You could say, for one thing, God spoke and the world came to be, but then the whole notion of something being created in the first place, it raises the question of, well, if something's created, if there is no universe and then suddenly there's a universe, right?
Mm-hmm.
Either there's magic doing that, like in the the sense of it being something that's unexplainable and irrational outside of any comprehension, or what you're saying is that it does exist, but the reason that it exists is not part of this physical universe. It's something from outside this physical universe, which means that there is something more fundamental than this physical universe, which means that our world is emergent from a world that is more fundamental than this world. And so by extension, then, the notion that we think of physical reality as being this fundamental thing, fundamental space in which all else exists, that becomes apparent that that's an illusion. There's something there that we're seeing that we're calling space and time, but this notion that it's a fundamental reality in which matter and energy exists is an illusion. So the whole notion, if you think about it for a second, the whole notion that there was no universe at one point and then there was a universe suggests that there is this creation, or this the rules of illusion.
Some physicists are coming to the conclusion that consciousness is before everything else. Before. I mean, would that kind of dovetail with the idea of the simulation that the consciousness is where this supposed simulation, or whatever word you want to use, is where the simulation might be taking place, is within that conscious being, whoever. Let's call them God. It's an easier word, right? But that's one of the terms that people are using is consciousness.
You can there's a number of ways to reach that conclusion. Actually, you can get that, or from a couple lines with physics, but then at a more fundamental level, you can get it with philosophy as well. You get it with a hybrid arguments between philosophy and physics combined, or you can get that with just philosophy. And it's some really simple arguments from philosophy that point this out, is that this is going to blow your mind completely when you see this. It's literally something that is not even physics. It's not even. It's the most fundamental. When you realize you were aware of it the whole time, and you're like, "What happened? Why didn't you see this before?"
I'm ready. Blow my mind.
All right. So when you start with epistemology, it's just how you know things, very very basic, right? You start with Descartes' Cartesian skepticism argument, right? He says, "I could be dreaming, this could all be some evil genius putting this over mine, but the one thing I know for absolute certain is that my mind exists. Even if I'm a brain in a vat or whatever, my mind still does exist, even if everything else in the world is an illusion." Okay, and so from that point, that's the starting point of epistemology, right? Mm-hmm. And so if something is, when you call something knowledge, that knowledge is justified true belief, right? You know something, if something is true, you believe it, and you have justification in the form of a logical argument for it, right? But then what does a logical argument ground itself on, right? It has to ground itself on premises, and those premises have to be true. And in turn, you ground that further, and you realize, well, those premises, what justifies those premises? And they need arguments for themselves, and you ground those on further premises still. And at some point, you have to stop it on something that you know innately. And all arguments, ultimately, if they're going to be really justified, I mean, for pragmatic purposes, we oftentimes just make certain assumptions and start there because we don't have time to, prove the outside world and all that. But in a principle, in principle sense, it has to be justified on something that you just know innately. And the only thing that you know innately is consciousness, right?
Mm-hmm. That's right.
Well, if you know the only thing innately is consciousness, and you turn that into a logical argument, what that would look like is premises, right? And those premises have logical terms in them, A, B, and C. And A, B, and C refer to things relating to consciousness, minds, thoughts, perceptions, etc., right? All mental things, right? Well, when you start an argument with premises with certain terms in it, you can't just have new terms appear by magic that are not in the premises, right? It wouldn't logically follow, right? So therefore, any conclusion you could ever draw that would be properly grounded on, what you know, which is just how proper epistemology is set up, would have to be in terms of mental items. You have to be referring to mental items. And so, because you can only start with your only way of knowing about the world is starting with your own mind and its thoughts and ideas. The only conclusions you can draw about the outside world is that the outside world is defined in terms of minds, thoughts, and ideas. There is one way out of that, but the only way out of that is to say that you can't actually access the world and reason about it, because there's no train of logic that can reach from your mind to the outside world.
Okay.
So if there is an outside world that we are interacting, and this kind of turns everything on its head too, because people often assume that idealism makes science impossible because it means that you can't study the world. There is no world out there to study, and that's not true, right? What it's saying here, though, is that if there is an outside world that you can study, that world has to be logically related to your mind. And the only way it can possibly be logically related to your mind is if the outside world has a mental ontology itself. Another way to think about this is you never, even if you were a dualist or a materialist, the only thing that you actually interact with, you never actually interact with anything material in itself, even what you think is normally material. I mean, look around you, right? You think the books on the back shelf are material. That's your assumption, right? Sure. Even if you don't believe it, this is how people assume the world to be.
Okay.
Well, if you think about it carefully for a second, you never actually see the matter. You see there's colors on them, right? Those colors are not, that's not matter. Those are qualia. That's immaterial qualia or perceptions.
Okay.
You think about that, like, wait a minute, that's something that's uniquely mental. You cannot explain. You can say there's red and that's a specific wavelength of light, and it hits the cones of rods in the back of your eye and sends a signal in your optic nerve and all that. All the science of that, but you can never, from that science, actually deduce the qualitative experience of redness or blueness, or the taste of
Right. If
chocolate,
you're trying to
etc.
explain it to a blind person, explain the color red, you'd be like, I can't. There's no
Exactly.
way
You can give
to
that
explain it.
blind person all the knowledge in the world about the color red, and he would have no idea what the color red was. There's actually a
Right.
thought experiment in philosophy of mind called Mary the Color Scientist that does just this. And there's a color scientist locked in a black and white room since birth, and she is given complete scientific knowledge of the color red. She's never seen red, and then when she leaves the room, she learns something new when she sees red for the first time
Hmm.
on a rose or whatever. And that's
Yeah. That sounds like a lot of theologians. They know everything there is to know about God, but don't have a clue about God.
yep.
Oh, I guess we're all going to be guilty of that. But okay, so we have qualia. We have this philosophical deduction of how there has to be mind before matter. What about in the quantum, or let's call it the physics world? What other evidence do we have that we're actually looking at mind before we get to matter?
Um. Well, say we look at quantum cognition. This is a good example. You have a situation where we found out that space-time emerges from the quantum state and the wave function, and that's actually you can learn that. Not you. I mean, that's a big thing in quantum gravity, but you can also learn that with just standard science and quantum mechanics. I mean, Sean Carroll had this whole, this clip of him in this lecture where he's pointing out that, space in quantum mechanics, it doesn't really exist. We speak of space as though it's something that the wave function exists in, but that's just a mathematical way of describing it. And in reality, space is defined by the wave function, and the wave function precedes space. So there's this deeper level of reality, and it is defined in terms of Hilbert space, which is the mathematical space of quantum states. And that exists prior to space, and that has specific rules, and it behaves in specific ways as superpositions in this quantum wave function, which has certain mathematical properties to it. And what they found is something quite astonishing, kind of completely incidental at first. And let me give you an example. What's your favorite ice cream?
I'll go with chocolate.
What's your second favorite ice cream?
Probably caramel.
Okay, so when you put caramel and chocolate both in your freezer, and you walk up to the freezer and you open the door and you're about to pick one or the other, right? And you might go to the chocolate because you like it more, but that's not going to be the case all the time. And when you do, each time you do it, you're usually not going to just pick one of them immediately. Now, if you were a Bayesian classical computer and you just did these 1-0 on-off computations, there'd be no thing in your
No
mind
delay or something. Yeah.
no delay in your mind, no hesitation at all, or uncertainty as to what you're going to pick.
Mm-hmm.
You're just going to know, no doubt in your mind, I should say. But the thing is, in reality, you don't do that. You sit at the freezer and you waffle for a second, or 10 seconds, or half a minute even.
Or you have both.
Or you have both, yeah. So the point is you'll waffle, and this happens with a lot of decisions. People will pick one thing or the other thing, and they will oftentimes not decide right away which one they're going to pick. So they go ahead and they pick one of the other after this little delay of uncertainty, of deliberation, shall we say, and it's not a one on-off computation. And well, they discovered that there's something else that kind of resembles this fuzzy superposition, shall we say, of deciding between caramel and chocolate. And do you know what it might be?
I really have no idea.
I give you the word superposition as a hint.
Superposition?
It's quantum states. Quantum
Okay.
states do. The cat is both dead and alive at the same time.
There we go.
To choose the ice cream is both caramel and chocolate at the same time until you decide, and then suddenly it becomes one or the other.
Okay.
And they figured this is kind of an interesting similarity, and they realized that you can't explain this with classical logic, and so it has to be operating on some other kind of logic to make this work. And they did very careful studies of this, and they found out that our decision-making processes behave exactly with all the same mathematical properties as you would expect from a quantum state behaving. wave function in Hilbert space.
That's phenomenal. That
Yeah,
really
and
is.
they study, like, whoa, this is exact quantum mathematics. We can use this to describe what's going on inside your brain, and you can treat the brain as a big quantum field, as it were. I'm guessing it's now right now at the moment, a lot of them are saying that this is not literally quantum. It's just it behaves this way. The math happens to be useful for this, to describe it this way. There are some problems with doing that, though. For one thing, if it really was, a classical computer that was simulating a quantum computer, you'd have this problem of needing to unpack all of those superposed states, the dead cat and the live cat states. And when you unpack all those, a single qubit can have numerous states in it at once. So you have pistachio and vanilla and so on, mint chocolate chip, spumoni, and all that in the freezer. There's going to be a lot of states in superposition. You're going to take a while to choose, And so with that, you'd have all these multiple states in superposition. And when you try to unpack those, a single qubit, what's stored in the information is stored in a single qubit. When you put that out into classical physics, you're going to have a bit for every one of those states stored in superposition. So you'd have to take the quantum states and expand them exponentially. And with the effect of this, it would number one, it would take the hard drive space. It would take huge amounts of hard drive space very quickly. Just like a single simple system with lots of qubits in it, or like a couple qubits in it that have multiple states in them. You'd unpack that, and suddenly it would fill up like half the hard drive space, and that's just on a simple program. And furthermore, then to process that with a classical computer, it's going to take an exponentially slow amount of time. And they call this the Feynman universal simulator problem. And so the problem is if our brains behave quantum, they have to actually be quantum. Otherwise, our brains are going to slow down exponentially.
Interesting. Our brains, some people's brains seem to slow down. Mine,
but they're not. Yeah, well, everyone's does. Mine even does at times. But it's they're going to have to slow down to the point where it's like literally like your computer freezes up for like 2 minutes and then spits out an answer to everything. And we just don't see that. We don't do that. And so because of that, it's only logical to conclude that the brain is in fact quantum mechanical. Wow. And there are a number of other things. Now, you could, they're trying to find the exact location. They have some theories about this, and some people were kind of ridiculing this because they said it wasn't at the right time scale for quantum effects. But since then, they found possible structures in the brain that would fit this. And we can rule out for other reasons that it can't be non-quantum because there are certain philosophy of mind criterion that any theory of consciousness have to meet that can't be met by a materialistic model, and they have to be met by something that is quantum mechanical that can bridge the subject-object gap, right? Because you can't solve Chalmers' heart problem and so on. So there has to be something there. They have some ideas now. Recently, the most recent one had to do with entangled lithium ions in the brain and so on. And so the idea here is that putting this together, the mind is in the superposed state in the wave function. All right? And because of that, and there's no real difference between the wave function in my brain and the wave function in, generating the leaves in the tree out in my yard, right? So there's not really there's no reason one should be mental and the other one shouldn't be. They're both quantum states, right? They're both, the same basic thing. And so there's no reason to say that the quantum state that's generating the tree out there is also not mental. And by extension, the whole universe is a simulation inside of this quantum state, or large quantum state defined by the wave function of the universe. And so you have this situation where there's this whole that Hilbert space we've been talking about, quantum mechanics, can be translated to be a cognitive space, an inner cognitive space, describing thoughts and emotions and how they interact and process.
Well, let me just stop you for a really quick second here. So if does the tree have consciousness? Is that what you're saying?
No, it doesn't have consciousness, but it is generated by consciousness.
Okay, now how
much like in a dream.
How is this different than, say, pantheism, where God is sort of?
Well, the difference with this is that it's not that. It would not be like animism, for example, where people would say that there is this. The trees have spirits and the rocks have spirits, and the wind has a spirit, etc. It wouldn't be like that. It's that these things are being generated by a single mind. So much like how when you dream, there are such things as wind and rock and trees and so on, but that doesn't mean that your dream is animistic in its properties, right? It just means that there is something in consciousness, much like an idea is. A single idea in your mind is not a mind in itself. In some exotic case, it could be, but it doesn't have to be. But but it's it has mental properties and it's in consciousness. And so the tree would not have a mind of its own. It would be a simulation of a mind, a product of a mind.
Okay, so the tree is a simulation. So we kind of go back to the idea of the Matrix movie, where
but instead of a computer, it's a mental simulation.
Okay, so essentially all of this stuff exists in the mind of God. We're essentially in the mind of God, but He's given us the ability to make choices, independent of Himself, which is pretty incredible.
Yep.
And we can choose to go along with His program or to reject His program, and all of this stuff, and even the mind itself is operating on a quantum level versus the more classical Newtonian analog type style. Okay. And this also raises the question of which came first, the mind or matter. Now, your typical evolutionist materialist would suggest that there was the Big Bang, and then years passed, and then we eventually got to planet Earth, and then we got little single-celled organisms until eventually 50 trillion of these organisms developed into a single person, and somehow
eventually they create a mind, right?
Yeah, and so you've got the brain, you've got the tissue, but
they got it all backwards because mind is not something that evolves in this situation. Mind is something that is fundamental, and it'll manifest in creatures along the way, but that doesn't mean that it was produced by that process. It just means that there is this. It happens to show up in isolated systems with intelligent organisms and so on, or just conscious organisms. And so it's not that it's generated by anything. It's a fundamental thing, and everything else is generated from it.
Okay.
It's the fundamental Lego building block of the universe. And
so let's just recap for some of our viewers, just in case they're lost here. We started talking about quantum physics, quantum mechanics. We talked specifically about quantum entanglement. Just really briefly, the word quanta just means a small little part, kind of the smallest idea, that things are not analog. It's not like this, but it's like dot, 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 dot. Kind of like when you maybe turn your volume up on your car, and some of the newer cars, they go one click at a time, right? Where back in the old days, it was just one continuous turn, right? And so that's kind of the basic idea of the quantum, that things can go from one state to another instantaneously. When you have the electron in an atom, it jumps from one ring around that nucleus to the next one instantaneously. It doesn't just kind of slowly walk over, but it goes from one state to another, and that's called the quantum leap, of course. Then when we were talking about quantum entanglement, where you can have a particle, let's take it maybe a photon or electron, and it can be entangled. It can have a relationship, almost like a love relationship, with another one, and a change in one will automatically, instantaneously affect a change in the other. And no matter how far apart these particles are separated, they will always register a change in the other. All right, so that's quantum entanglement. And because it doesn't matter how far apart they're split, if you start considering this, it's happening instantaneously, which means that the transmission of signal, whatever it may be, is happening faster than the speed of light. And if it's happening faster than the speed of light, that would go against Einstein's theory of relativity. It breaks all kinds of natural laws as we understood them at least a while ago.
Yeah, well, the catch with that is it's not really breaking relativity because it's not actually traveling through space.
Exactly.
Because the space is the illusion. It's going underneath the illusion.
Right. So that's how we got to this idea of a simulation, right? So going back to the idea of the video game, if you're the guy in the video game, then everything appears to have space. But if you're outside the video game looking at it, you understand how something can instantaneously show up on that mountain way over there, because it's all just in a video game. It's all happening in the CPU, and it's just being put up on the screen, as it were. But the guy in the video game, he doesn't understand that, and it seems rather magical. So that's what we're talking about, non-locality. And again, that's what Einstein fought against much of his later life. But this has been proven time and time and time again. So we have non-locality, and that has led some people to believe that it's a simulation. And so now what you're doing is now you're bridging the gap for us by saying that not only do we have this quantum world out there, but we might even have a quantum world in here, in our very brain. Our brain is not sort of a classical computer, if you will, but it's more of a quantum computer, which would then tie all of the consciousness together. And by consciousness, at least for me as a Christian, I would say the big consciousness is God Himself. Okay,
Right.
Others might have a different definition, but as I've understood it,
system, etc.
Yeah, in my worldview, that would be God.
If it walks like a duck, quacks like a duck, talks like a duck,
it's a duck. Yeah, if it sounds like a creator, it sounds like an omnipotent being. It must just be.
Define things like omnipotence and omniscience and omnipresence in terms of the physics. So it's like, yeah, it fits those definitions as physical properties. So it would be what, in a scientific sense, what people would call God.
Yeah. Okay, so this is really fascinating stuff. I mean, do you think that there is a change happening in physics, or do guys just they shut up and calculate and they don't really think about?
A lot of them shut up and calculate, and well, the thing is that changes don't happen overnight. It's kind of a slow process. Number one, a lot of people holding different views, and then there's also, when people talk about paradigm shifts, and it doesn't really work that way exactly. I mean, in a sense it does, but in reality it's Max Planck actually pointed out that physics advances one funeral at a time. The old generation dies off and the new generation comes up. And
that's right, because Newton's
kind of speed things along and point to the newer generation that this is not a material world, it's a simulation.
Okay.
The new generation is used to computer games, so it's kind of easy.
So it's going to make perfect sense. They're like, oh yeah, okay, no problem, right? It's not a big shock to them. And the same thing happened in Newton's day when he came up with the idea of gravity. That generation that was concurrent with him was shocked by this. But then the next generation were like, well, yeah, okay, what's the big deal, right? And all of us have grown up with relativity, so we're like, oh, okay, yeah, that makes sense.
When it first came out, that was
like,
oh my goodness,
yeah,
you can bend space and go backwards in time. It's crazy. Quantum mechanics. Particles can be in two places. Niels Bohr, I think he said, was it Schrödinger? I think they were trying to figure this out, and this is convention. And he comes out, and he says, okay, this is what's going to go on. Just trust the math. This is going to sound absolutely insane, but this is what's going on. And he explains the particle is not anywhere. It's actually in multiple places at once, and you collapse it, and it's a probability where you're like what Einstein reacted, because the world's real. This is ridiculous, and not real. And then, well, they didn't really say. They kind of pushed off the issue of whether the world was real or not later, but now we're kind of tackling that now. So now we're realizing that yes, in fact, what we're calling the physical world is a simulation.
Wow.
Now, whether it be a literal simulation in the sim sense, or whether it just be a natural simulation in the sense of it being an illusion generated by quantum information. That's where quantum gravity is going now.
Right. And I just wanted to point out that you've created a video called "The Physics of Miracles." How do you tie quantum physics in with the physics of miracles? How do you? What's the correlation there?
Well, so the idea of the miracle there is, there's the normal behavior of the world, right? Normal programming, and it just behaves according to the program. Everything looks normal, okay? Well, a miracle would be a supernatural intervention into the natural world, right? But with this sort of quantum idealistic framework, that whole divide between natural and supernatural breaks down in a sense. There is a divide that is physically useful here, though, is that there is within the simulation, within space-time, what we call physical world, and outside of it, which we would call supernatural. The catch here is that the supernatural is not supernatural in the sense of being outside of science anymore. It might be better to call it superphysical. It can still be studied by science, but it doesn't have. It's not material. It doesn't have what you call physical properties. Has
I like
properties
that
you
term. I like that term much better. Super physical.
super
It's
physical.
about the physical world as we
Yeah.
typically think of it.
And so the idea then is, well, the programming is in the super physical world and it's underlying the physical world. And so you can then kind of go into the source code and tamper with the source code, and you basically create a cheat code and you can hack the world. And well, that would be, you know, the what you call the supernatural, the super physical, causing a change in the natural, literally reprogramming the matrix. And so that would be, by definition, a miracle.
Hack the world.
Yeah. And so the idea then is,
yeah.
the specific idea then would be, you know, how would you go about doing this? Well, the program is being run on these quantum waves. So a line of code is a wave function with a waveform pattern with a vibrational frequency and all that. So you essentially shift the vibrational frequencies of these wave functions, these quantum probability waves. And so doing, you change the underlying program. The qubits superpose differently and they produce a different program and a different outcome. You just, you know, turn the water into wine and so on.
So are you suggesting that Jesus was tampering with the source code? Is that?
Well, yeah, I mean, he had access to it. It's all in his mind, so it's direct access to it.
Okay. Yeah, I mean, yeah, certainly he's the code writer. Well, what about the rest of us? I mean, he said crazy, outlandish things like, "Hey, you know, if anyone believes in me, he will do the things that I did and more
Well,
so."
if everyone's connected to God, right?
Right.
It's kind of
Okay.
in the unfallen state.
Okay.
You know, the consciousness is no longer disconnected from God or kind of linked to God through the Spirit. And if you think that way, well, God's mind is what's upholding the world, right?
Mm-hmm.
So you have access to the consciousness generating the universe, and so it's able to, you know, heal or do miracles or make mountains jump in the sea and so on. And because you have access to the source code, you can control the source code now.
Okay, so that's an important distinction. There is, if you have let's call it a relationship, that would be the Christian word,
Mm-hmm.
but in the quantum, where you have a connection with
literally an entanglement. It would literally be an entanglement.
An entanglement with God. Wow, a divine entanglement. So if you have a divine entanglement with God, ooh, that's really rich. Wow. So okay, so if there's a divine entanglement between me and God, when things are going awesome, I'm really in touch, in sync with God, right? And I say to this mountain, be moved and be cast into the sea. Because of the entanglement, then that's going to happen. Not as a matter of, I mean, of course, God is a sentient being, right? He's not just a bit of code that we can just manipulate.
That's the code in his mind. It's not, you know, his mind itself. It's the code inside of his mind. So
right. Okay.
But you still have access to. You're connected to his mind. I mean, you can call mind in two different senses. I think there's the mind in the sense of the eye, but there's also the mind in the broader sense of there's the whole. You know, depending on what you mean by the word. So.
No, and I'm not trying to, you know, I'm not trying to put you in a corner or something like that. I'm just trying to understand how we can best understand this, because I think we're, you know, I feel like we're kind of on a nice little trend here, and I'm trying to see if we can't, you know, get a little bit more out of this. You know, but
that's it. It's an entanglement with God's conscious state would be defined by this universal wave function.
Okay.
At least insofar as the part of his mind simulating this universe is concerned. And so if we connect to that, we literally entangle with that quantum state connection to God, then suddenly we have the same access to the same code Jesus had access to, which he said, you know, you'll do greater things than these and so on.
Well, what if I'm doing things that are not pleasing to God? I'm murdering and I'm stealing, and do I still have that, or what happens there?
I mean, obviously your spirit would be wrong then. You'd be doing that out of God, you know. You lose the connection to God then.
Okay, so kind of keep it on that physics level, the entanglement would be broken.
Yes.
Because I'm now going in a different state than, you know, than this other part, right? Namely God.
Yeah.
Right. So now the entanglement's broken. So as long as there's an entanglement, the entanglement requires me to be on God's wavelength, if you will. And if I'm on that perfect wavelength with me, which means that I'm doing those things that please God, that things that God thinks.
It wouldn't just be like, you know, actions, right? You can do it like mechanically, like Pharisees. You know, a lot of people do that to various degrees, but it's You have to do it. You have to be with God's wavelength, God's God's inner state,
His character, right? So
that would have to be aligned as well.
I'm sharing in the character of God, and in other words, I'm aligning my character with His character, right? It's never that we're ever manipulating God, right? It's just that we're actually getting in tune with God, right?
Exactly.
Just like on a radio, I can tune the thing. And once I finally get it in tune with the broadcaster, then I can enjoy some nice music. But when I start turning the dial again, which we'll call sin,
it gets all fuzzy and disconnected.
It gets fuzzy, and then the connection is lost. Okay.
Yep.
Okay. Wow. All right. Well, that's enough to blow my mind for one day. That's really cool. That's awesome. That is very fun.
Yep.
I'll tell you, this kind of stuff is seriously interesting when you start to look at the Bible in a new way. And much of my life, I grew up with the Bible. I believed it and everything, but it was always religious. It was always sort of this if I could only be good enough kind of person, and it didn't really make sense because it was all just receive it by faith and that's it. And I love to take it apart and say, now wait a second,
what's going on?
God's word shouldn't be any different than, say, physics, for example, right? Because God is the creator of physics, right?
It turns out that it isn't.
Yeah, it should all fit together. And what we discover in the physical world should simply underscore what we already find in the Bible. And it's maybe different kind of language to describe things. But once I get beyond the Christianity or the Christianese or the religious language, and I convert it into physics type,
you can see that there's a pattern here, that this is not a coincidence, that they're interacting with the same reality.
Yeah. So that's the trick, is to sort of convert the Bible into physics language and maybe convert some of the physics into Bible language. And once we do that, we're going to be like, oh, I get what you're saying.
Now, I have an example of something like that in a very curious way. Well, firstly, I got to explain there's this notion of consciousness as entanglement. It's shown up in a mathematical theory of consciousness called conscious realism, which is a guy named Donald Hoffman, who lives about 15 miles away from me. Or he works about 15 miles away from me at a university. He's modeled this consciousness in terms of entanglement. And he said that if you have two conscious agents interacting with each other, they actually fit the definition mathematically of a single conscious agent in itself. It's kind of because you can have conscious agents building up into larger conscious agents at nesting scales, as it were. And I found recently a very interesting, very accidental consequence of this that was just mind-blowing. Before this, I got to explain a little about semantic logic, okay? Say you look up words in the dictionary, right? And those words are defined by war words, which are defined by war words still, and so on. And at some point, this loops back, and you have this big semantic web. You define all the terms in this big logical system you call the dictionary. And if you were to break this apart further, you could say, let's convert all those definitions, it would be very tedious tasks, of course, but you could do it, into actual, valid logical propositions, like if, then, and statements, right? So you have different operators like this, right? Then, and, or, etc. You can then further say, you can make it simpler. Like you can say, wherever the term A and B appears, right? Or leaves and trunk branches appears, right? Or leaves, branches, trunks, and roots appears. You can just replace that with the term tree, right? You could just you lose some. People would know what it's talking about, but you lose some richness in the language, but you'd still have an understanding of it. Would still be the same logical system. You could reduce the system by just replacing wherever that appears with the term tree. And you could keep reducing this in theory ad infinitum, and you can do this down to a point where you get down to exactly 3 elements in the system, right? And those 3 elements, well, they have to define each other. Like the definition of A will have to include the complete semantic content of the meanings of both B and C. The definition of A, all the semantic content that defines A, will have to necessarily incorporate all the semantic content that defines B and C. It literally encompasses the other 2 terms. And likewise, B would encompass A and C would encompass A and B. And the reason for this is if you were to take out one of these terms, right, make a simple. Say you'd say that A is defined by B, but not by C, right? And so on. Well, the problem then is the only thing that defines A is B, right? Well, what defines B, right? Well, it's A again. Well, what is it about B rather that is defining A, right?
Mm-hmm.
Well, since the only way A relates to B is relates to the whole system is through B, you have to be a tautologist relationship. A defines B, B defines A, and there's this doesn't really mean anything. It's just it collapses, right? All you have left there is B and C, and then B and C would likewise define each other in a tautologist fashion. And so, if you were to separate any semantic element that would define the whole system here, the whole system would collapse to tautology. None of the terms would be meaningful. And so the only way to have any semantic meaning in this is if there is this this relationship where A and B, A literally encompasses the definitions of both B and C at the same time. Literally is, in a sense, both B and C are define each one of these three terms defines the whole system. Okay. Now you can then you look at Kaufman's conscious agent dynamics, where he has these conscious agents that are connected into two agents create a third agent and so on. And you could then do this with arbitrary numbers of agents. You can create this with these webs of agents, which would have the same syntactic relations as the semantic elements in the dictionary, right? Mm-hmm. You get the exact same logic here, the same semantic logic I just did in the dictionary sense to these conscious agents. And so you say you want to make a maximally simple conscious agent, right? So you combine these and you get down to the most fundamental level, right? Where these conscious agents are the most the simplest, most fundamental level of reduction of combining these into a simple system. And at the very bottom level of this, you find something very curious, is that, well, if you have A communicating with B, right, and there are no other elements to define what A and B are, like say other, individuals, say there's the system of black, white, horse, and zebra, okay? You get rid of zebra without losing any of the semantic content of black and white, but at the same time, that zebra is, the black and white are related to the meaning of zebra and vice versa, even if they're not directly related. That's one example of what black and white is referring to as zebra. So you can get rid of that, but then you have these other system with these three elements in it, right? You can't dispense with one of these elements, and so the semantic content of these agents would be indistinguishable from each other. They would be the same agent producing a larger agent, which wouldn't make any sense. And so the idea then is what you do is you have one way around this at the simplest level that before it reduces into tautology is three agents, right? Three conscious agents combining to produce a single conscious agent for a single mind, right? Mm-hmm. Now here's the catch. The content of the mind or the mind itself is defined by its semantic content, right? All your thoughts and ideas and emotions, etc., right? Well, the thing is each one of those individual separate conscious agents encompasses the semantic content of the other two conscious agents, right? For the same logic I just used before with the whole, A has to encompass definitions of B and C in their entirety, otherwise the whole system implodes into tautology. Mm-hmm. Well, A conscious agent has to necessarily encompass the semantic content of B conscious agent and C conscious agent. And by semantic content, I mean literally their mental identities. Like the whole would encompass the entire mind of both B and C, and likewise, B would encompass the mind of A and C, and likewise. They're all part of this big mind. You can't dissociate them. But the thing is with this is that you call them personal identities, shall we say. You kind of anthropomorphize it and take these mental identities, call them personal identities or persons, and so you have this. See what I'm describing here?
Mm-hmm. Okay.
It's the Trinity. It's a Trinity. You're getting out pure by accident out of Hoffman's conscious realism and the cumulative result from semantic logic, where at the simplest possible system, each one of these semantic elements has to contain the semantic content of the entire system, including the other two elements. Otherwise, the whole thing implodes.
Oh, that is seriously cool. Oh my goodness. Yeah.
I mean,
so
you ever thought the Trinity seemed kind of like this weird, like illogical sounding thing? We take it as true, but what does it mean to make sense of this?
Yeah.
But now, like crazy, like it makes sense. It's weird, but it makes sense.
It is really weird. So the Trinity, it's the Trinity is challenging, and yeah, the triunity of God. That yeah, how to put that in exactly. But that's interesting. I mean, that's really fascinating.
Yep.
I'm just thinking that in the ancient book, they're called the Zohar. Some people might think that's a
Yep.
blasphemous book, but um, it's interesting because in the Zohar, the rabbis actually talk about there being a trinity. I mean, they don't use the word Trinity, of course, right? They would never do that.
Right.
But like you said, a rose by any other name is still a rose, right? And
Mm-hmm.
so, just because we use a different word, it's still the three in one, and that's what I think is
Mm-hmm.
very
Yep.
powerful. And I have this on my website, and so they have the Zohar three in one in Hashem's Kedusha, Hameshuleshet. So the ancient holy one is revealed, found in three heads, with three heads,
Mm-hmm.
which are united in one, and that head is threefold exalted. The Holy One is described as being three. It is because the other lights, the other two, emanating from him are included in the three, yet the Ancient One is described as being two, Daniel 7:13. The Ancient One includes these two, that is, the two are found in him. He is the crown of all that existed, the chief of the chief, so exalted that he cannot be known to perfection. Thus, the other lights, shining ones, are two complete ones, yet is the Ancient One described and complete as one, and he is one, positively one. Thus are the other lights unified and glorified in one because they are one. I mean, you read this like, oh my goodness, I hear people out of, they badmouth anything Jewish, and I'm like, these guys got it. They were
They
obviously,
got it.
mystical, but you need something a little bit mystical to understand something like the Trinity, and you're doing
Mm-hmm.
in physics talk, right? But
Mm-hmm.
that's kind of mystical too, right? Because we
In a
still don't
sense.
know what makes the whole quantum entanglement stuff work. And that's
Well, we
kind of
do actually, in a sense. I mean, it's the whole virtual reality. Well, actually, it doesn't just because it's mystical in that sense. I suppose you want to call that mystical doesn't mean that it's necessarily irrational, as it were. It can be like
sure.
it's kind of funny. Wolfgang Pauli actually described quantum mechanics as quote lucid Platonic mysticism once. Like it was mystical, but it was not mystical in a way that was mysterious. It was
Okay.
mystical because it had this level of consciousness tied into it in this fundamental fashion, and there's this
Yeah.
different mode of reality, but it was
Yeah.
everything about this reality was also rationally explicable and graspable by science and so on. There was no. It's kind of weird, It's you're seeing something that it can't be, yet it all makes sense.
And it really makes sense. I mean, that this shouldn't be so difficult for us. I know that there's still a debate raging among physicists as to exactly what are the implications, and that's of course the challenge is what do you want to allow into your paradigm, right? If you're all
Mm-hmm.
about locality, then none of this stuff makes sense, and you might want to just shut up and calculate and not worry about any of this stuff. But if you're wanting to go beyond that and say what are the
What does this
implications of
mean?
this, what does it mean, why is it this way, then you really have to start looking at other things. And the idea of the simulation being in the mind of the creator God
Mm-hmm.
is one that really does resolve all of these issues, because now you can have non-locality. You don't have to have everything grounded by
Mm-hmm.
space-time. It can actually be in a different dimension, if you will, or some subcode that we don't fully
Mm-hmm.
understand, and it's operating on a different level. So it's just fascinating to look into these things and to consider them. I would just encourage people to look outside the box. Sometimes we can get so narrow-minded, so much entrenched in our own particular theology, our own way of understanding the Bible or the world around us or God, or however whatever you want to look at. But if we are willing to take a look at another perspective and say, well, what if, right? I mean, there's certain fundamentals. There's a God, okay? There is a creator. And now it's exciting because science is actually getting to the place where they're saying, hey, there has to be a creator. Consciousness has to come first. And I hope that would cause us to reassess our paradigm and say, well, what can I learn? maybe I've got a little bit of the truth, but maybe I'm missing something, right? And it's not to say that we we don't throw out the Bible, of course, but we allow these concepts to help us better understand
What's
these
going
things that
on?
Jesus was talking
There's this
about.
framework,
Yeah, yeah. Because I keep meditating on Matthew 21:22. Pray for anything, and if you have faith, you'll receive it. I mean, there's something about that Jesus was saying. There's something about Peter
Yep.
walking on water that is, wasn't just because God was like, okay, I'm going to make it all happen now. But yet, if it were all God's power, so to speak, why did Peter stop believing and then fall through, right? So
Yep.
it's not just that God willed it to happen, but I think that God created the universe for these things to happen, and our belief or disbelief will directly impact how much of these, this coolness that we get to experience. And so, I don't know. It's a really interesting quest to kind of put it all together. And I want to thank you for coming back on the show to for blowing our minds again. Thank you for that. And everybody, if you're interested, I found this to be I'm not done with it yet, but it's called Spooky Action at a Distance. I got it at the library, George Musser. It's pretty cool. And he talks about some of the history and all this stuff behind quantum physics. Why am I so interested in quantum physics? Because I really believe that God made this universe way cooler than we have been led to believe. And quantum physics is something that's, it's quantifiable. It's something that's observable. It has been repeated countless times in the laboratory. So it's not just some wacky, metaphysical idea that some guru on top of a mountain came up with. This is something that's based in reality, and yet we discover that reality is weird. Reality doesn't really take shape until the creative, or I should say the conscious observer, actually takes a look at something. And what that says to me is that God created the world in such a way that he expects us, he wants us to be participants in what happens down here. And if that is our birthright, then I suggest that we take complete advantage of it. Now, again, you cannot use it for for the wrong way. You need to get in sync with God, and once you do, then these incredible things begin to happen. If you continue to go against what God said to do, you may have little points of success, but ultimately it will all be a failure, and it will all denigrate and degenerate. So we want to get on God's wavelength. It's our choice whether we do or not. It's our choice whether we believe him or not. He doesn't make us do it, but he gives us the opportunity to participate in this universe that he has created. Pretty cool stuff. And amazingly, physics is helping us to understand that. So pretty awesome. So Yohanan, just again, thank you. I want to encourage everybody to go and check out your YouTube channel. You can go to youtube.com/user/Yohanan Raatz. That's Raatz. He's got some awesome videos there, and if this didn't blow your mind enough, go check those out. They're really nicely produced videos. One is the physics of the miracles. Is the universe simulated in a mind? He's got another one, Through a Mirror Darkly, and more, where he is discussing and helping us to understand some of these things. And your newest one, it looks like, is the integrated triad. So that sounds, I think we touched on some of that.
That's the topic of that video is what we discussed there.
Yeah.
Literally the whole, I synopsized that video.
That's awesome.
That's the derivation of the Trinity from conscious realism and semantic logic.
Yeah. Well, I want to thank you again for coming on. It's always fun. I appreciate you blowing my mind and everybody else's. So thanks again. Everyone, stay in the Word. I'm telling you, God's Word will change you. It will excite you. It will encourage you. It will challenge you to live in new ways. And when we take it literally, when we start to really say, this is what it says, it's got to mean this. I may not understand it today, but by golly, I'm going to understand it. I'm going to keep digging and try to get to the bottom of this. And And then it's amazing. Things just start to open up, and God says, hey, check this out. And you're like, oh, wow. And it's really exciting. So it's not spooky action at a distance. It's just the cool way that God created the universe. Till next time, everyone, God bless you. Stay in the Word.